Hello, my fellow Java code geeks. This is Andy, and today we're talking about artificial intelligence, specifically goal trees. We're going to start off with an example scenario just so we can understand exactly what we're talking about. Then we're going to talk about what is a goal tree. And finally, we're going to create the example scenario using Java. Now, complementary to this video tutorial, you can find related articles and resources in the description below. Of course, you may visit Java Code Geeks and stay up to date with everything Java related. Just before we continue, if you guys like these guides and videos, take a minute to subscribe, like, and don't forget to hit that notification bell, just so you know when our next video is up. So, without further ado, let's get started. So let's consider a train yard. We have all these cars on a whole bunch of different tracks. I've numbered them so we can talk about them more easily. And on the right side, we have a conveyor belt that can move train cars from one track to the next. Some of the things that we may want to do here is we may want to, say, put car 15 in front of car 14. Well, that's easy. We move car 15 over to the right onto the conveyor belt. The conveyor belt moves it down one track, and then we move car 15 back to the left, so it's now in front of 14. That's easy. We could do that right now. But what happens if we want to put car 6 in front of 14? That requires a little more thought and planning. We can't just move number 6 in front of 14 because this system operates under certain rules. One of them is we can only move one car at a time. That's because the conveyor belt is only so wide and it can only move and handle one car at a time. So in order to move 6 in front of 14, well, we have to do a couple of things first. For example, we need to get rid of car 15. Which means we have to find an empty track to move it to. We'll do that, and then we can move car 6 in front of 14. Something that's a little more complicated, more involved, is what happens if we want to put car 6 in front of car 10. Now, not only do we have to get rid of car 15, which is in the way of 6, but we also have to get rid of car 14, which is in the way of 10. And this is the system that we're going to program and take a look at. So first of all, let's take a look at the demo. Okay, now as you can see, the cars are in different orders. There are different cars, they're in different tracks. That's because when I run this demo, all the cars are randomized. So let's enter a command. So we can click this button. And what command are we going to do? Well, let's start by putting, let's say 11 in front of 12. So let's write put 11 in front of 12. Okay, it's telling us that we've received a command. This is the goal that it wants to accomplish. And then when we process the goal, it puts 11 in front of 12 because it's available. 11 is free, there's nothing in front of it, and 12 is free, there's nothing in front of it. Now, what happens if we enter a different command? Let's try and put 7 in front of, I don't know, say 6. Okay. Now, let's see what it comes up with now. Remember, this is a program. This program will be thinking about the steps it needs to take in order to accomplish its goal of putting 7 in front of 6. So the first thing it needs to do is it needs to clear the front of 7. Well, how's it going to do that? Well, it's got to get rid of 9. 9's in the way. Once that's done, 7 is clear to move, but we can't just put 7 in front of 6 because 6 has things in the way. We have to find space in front of 6. How do we do that? Well, we got to get rid of 8. Well, how do we get rid of 8? Well, we can't just get rid of it. We have to clear the front of 8. Which means we got to get rid of number 14. And once we've done all that, 7 will have nothing in front of it. 6 will have nothing in front of it. We can go back up and accomplish our original goal, put 7 in front of 6. Let's run this and see how it looks. As you can see down here, it's printing out the steps that it's doing one at a time. And there we go. That's perfect. Now, one characteristic of an artificial intelligence system is you should be able to ask it about its behavior. Why did it do certain things? How did it do certain things? So in this demo, we are going to allow the asking of why questions. Why did you get rid of, let's see, get rid of 14? Why did you get rid of 14? Well, let's take a look. If we say okay, it's going to answer us because I was trying to do the following. Clear the front of 8. Take a look at our tree. Remember, 14 was sitting in front of 8, so we had to get rid of 14 in order to clear the front of 8. So that's why it did it. Of course, you can also ask a question, why did you put 7 in front of 6? And if you type that question, that was the original goal. It says, well, because you told me to. That was why I did it. Pretty simple. You can also ask how questions. How did you get rid of 14? Oops, I typoed. How did you get rid of 13? Oh, so you see what the system will do is it'll recognize that, well, it didn't really do that. So it's going to ask you, did I do that? Of course you didn't do that. So let me type that properly now. How did you get rid of 14? What did it do? I moved 14 to an empty track. Great. Let's try another one. How did you put 7 in front of 6? And what did it do? Well, first it cleared the front of 7, and then it found space in front of 6. And then, of course, it put 7 in front of 6. So that's a characteristic that we're going to also be programming for an artificial intelligence system, is to allow you to query it. Why did it do something? How did it do something? So here we are back at our presentation, and let's think about first, what kind of functions or methods are we going to need in order to accomplish our goals? So the first thing we definitely need is, well, we need some kind of a way of putting a car in front of another car. So whatever the mechanics of that are, I mean, we know what the mechanics are. We move the car over to the right onto the conveyor belt. The conveyor belt moves it to the track that it needs to move to, and then we move the car to the left until it hits the car, until it hits the first car on that track. That's put in front of. But it's not that simple because there could be cars in the way. So, for example, we may need to clear the front of a car. So if we want to move, say, car 10, we're going to need to first clear the front of car 10. Well, how do we clear the front of car 10? We have to get rid of another car. So we're going to need that kind of functionality as well. So now we have identified 3 things that we're going to need to do. We're going to need a mechanic to put a car in front of another car. We're going to need a mechanic to clear the front of a car, and we're going to need the mechanic to get rid of a car. Now, getting rid of a car actually calls itself recursively because we may need to get rid of multiple cars. For example, let's say we're trying to move car 11. We have to clear the front of car 11, which means we have to get rid of car 12, the car in front of it. However, car 12 can't be gotten rid of because there's a car in front of that. So we're going to need to get rid of car 13. So as you can see, there's a little recursion going on there. In addition to all of this, we're going to need a mechanic to find space in front of a car. If we want to move car 15 in front of car 10, for example, we need to find space in front of car 10, which means we're going to need to get rid of car 14. And of course, find space has a little recursion in it because if we want to, say, put car 15 in front of car 1, we need to find space in front of 1, which means we need to first find space in front of 3, getting rid of car 4, then we can get rid of car 3 because we can only move 1 car at a time. Now, all of these mechanics, what do they have in common? Hopefully you've guessed it, they're all goals. This is what we're going to be programming. This is the concept behind a goal tree. We create goals, the computer figures out which goals it needs to accomplish, and then it figures out the steps it needs to take in order to accomplish each goal. And it's going to build a tree. We're going to take a look at a specific example, put 6 in front of 10. Now, as you can see, 6 has a car in front of it, 15, and 10 has a car in front of it, 14. So let's start building our tree of goals. Well, the first goal is put 6 in front of 10. That's what we've told it to do. So what are the steps needed in order to accomplish this goal? Well, the computer figures out that, well, it's got to clear the front of 6. But then it's also got to find space in front of 10. Now you notice I've left a little space here because each one of these goals has sub-goals that it needs to accomplish in order to get them done. For example, how do you clear the front of 6? Well, you got to get rid of car 15. How do you find space in front of 10? Well, you got to get rid of car 14. This is a goal tree, as you can see. Now let's talk about a why question. How would the computer be able to answer a why question? For example, why did you get rid of 15? Well, if you take a look at the tree, you can kind of see the answer. The answer is because I was trying to clear the front of 6. Okay, so why did you clear the front of 6? Well, because I was trying to put 6 in front of 10, and I needed to clear the front of 6 so I could move it. Hopefully by now you've seen that a why question is answered by just going up one level in the tree. Let's consider the how questions. How did we find space in front of 10? Well, what's the answer to that? The answer is that, well, we got rid of car 14. So pause the video for a second and think about how are these questions answered. Hopefully you've seen it. If the why questions are answered by going one level up in the tree, the how questions are answered by going one level down in the tree. How did you find space in front of 10? Go down one level. I got rid of 14. How did you put 6 in front of 10? Go down one level. Well, I did two things at that level. I cleared the front of 6, and I found space in front of 10. So now let's head over to NetBeans and actually program this scenario. So here we are in NetBeans, and I just want to start out by saying that the purpose of this video is to teach artificial intelligence and goal trees. It's not to show you how to pop up a frame and do graphics and this and that. Now, we are going to go through all of that stuff because that's necessary in order to get this demo up and running, but we're going to go through it a little fast. So if you really want to learn that stuff, there are other videos that you can watch that will teach you that. That being said, let's get started and go through some preliminary code. Right now, we have this launcher, which is just a main class. It instantiates an object called goal trees, and then it calls a start method. Let's go over to goal trees. Now, this is the main class that's going to handle the graphics. It's going to implement runnable, and as you can see here, we have, let me scroll down to the bottom. We have our standard run method. We're going to initialize stuff. That's our method. We'll write that. I'll get up to that in a second. This code here and this code here ensures that the game is always going to run at a consistent speed. If you have a fast computer or a slow computer, they may tick at they may have faster or slower processors, and the game may appear to be running either faster or slower than on a different computer that is, say, older or newer. Now, this code here will ensure that every single time you run this, no matter which computer you're running it on, it'll always go at 60 frames per second. So just a quick overview of this code. We set our frames per second at 60 per second. The time per tick is 1 billion. That's how we measure nanotime. And we're dividing it by our frames per second. And what we're doing is every time we're going through this loop, we're checking to see how long has it been since the last tick. Remember, when you're writing a program that's graphical, you're going to have two main things that are going to be running over and over again. You're going to have a tick method, which is going to update your variables and do your processing, your demo processing, or if it's a game, your game processing. And then you're going to have a render method, which is going to basically draw everything. So these are the two things that are going to happen over and over again. As you can see, they're the only methods being called inside this while loop. Now, this is basically making sure that we have not done this beat of the demo or tick render combination quicker than 60 times per second. So we're going to keep track of the time since the last tick, and as soon as we get above a certain threshold, we tick, we render, and then we update this. So that way this will not happen again until the specified time, in other words, 1/60th of a second later. Okay, of course, now we're going to be using a thread, so we have a start method. It's going to be synchronized, so only one, this can only be entered once at a time. We're creating a new thread. We're starting the thread. Here's where we're stopping the thread. And of course, we have some basic getters and setters. Get the width, get the height. Now let's quickly go up to initialize, because I said we would. Here is initialize. Okay, so we have our title. We're going to set our width and our height to 1500, 800. You can change that to whatever you like. And then we're going to create a display. I like to have my display in a separate class. That way it keeps things separated for me. So now what are we going to be doing inside the tick method? Right now, we're not going to do anything. This is where we're going to do our processing, changing our variables. But in our render method, well, we're going to use buffer strategy. Again, that's a topic of another video. We're going to use two buffer strategies. And then what we're going to do is we're going to tell the buffer strategy, we're going to draw our graphics. We're going to clear the screen. All right. We're going to draw everything. Notice there's nothing here yet because we haven't created anything to draw, but this is where we're going to place it. And then we're going to tell the buffer strategy that we're done drawing so you can render it to the screen. And then, of course, we're going to dispose of the graphics object. All right. Now, we also have a getter method, get display. This actually belongs down here in the getters and setters. I like to keep everything together. All right. And that's going to be a way for us to get our display object just in case another object needs to use it. Now, what's in the display object? Well, it's pretty basic. It's just so we pass in the title, the width, and the height. We also were going to be passing in this object. Now, this object, gold trees, is a glow. It is the main object of our demo. It's going to contain certain objects. It's going to contain the display. It's going to contain other things as well that we're going to need. And you'll see as we go through all the different things that are going to be stored inside this class. Now, for that reason, we're going to need access to everything inside this class. So we're going to basically take this, the instance of this class that we created in Game Launcher, and we're going to pass it around to every single object that's created so it can access it. So anyway, what's in our display class? So our initialize, okay, here's where we could create the frame. Here's where we create the canvas. We're going to add the canvas to the frame, and then we're going to pack it up. Now, any other things we're going to be adding, like, for example, buttons, which we will, we're going to put right here. So let's just put a little placeholder comment. Add all of the other things to the frame. Okay? And then, of course, we have some getters and setters. We can get the canvas, we can get the frame. So if we run the program now, you can see that we're just going to get a blank frame appearing on the screen, and that's exactly what we want. All right, so now we're going to get into programming the train car. So first thing we're going to do is we need a little preliminary code. We're going to need the ability to display text on the screen. So let's create a new class called text. All right. And the only thing inside this class is going to be a drawstring method, and it's going to be static because we want to just be able to call this method and draw a string anywhere we want on the screen. And the things we're going to pass in are the graphics object. We're going to pass in the string that we want to display. We're going to pass in the X position and the Y position of where we're going to display it. Remember, that's always the lower left position. Let's pass in a Boolean, and this will be a flag that determines whether or not the text is going to be centered around the point that we pass in, or whether this point that we pass in is going to be the lower left position. And of course, we need a color. All right, so that takes care of that. Let's open our parentheses. Oop, I already have that already. Let's get rid of those. Okay. What do we need? Oh, okay. We need to import graphics. We need to import color. That should be good. Okay. So now, normally we would probably want to pass in the font, but for this purpose, we're just going to say we're going to use one font. So let's create a font. Okay, there's our font. We're also going to need the width of the text, the height of the text, and the border. The width of the text and the height of the text, I believe, is what we'll need. So let's create variables for that. Okay, there we've set our font, and let's just do the basic stuff. Okay, so what we've done here is we've gotten the font metrics, and now we know the width and the height of the text that we are about to display. This way we can center the text if we need to. And now we'll just display the text. And there we go. There's our text class. This will allow us to draw a string anywhere we want on the screen. Now, the other thing we're going to need is we're going to be handling positions, like an X and a Y position on the screen. And I don't want to have two variables for that because it makes it difficult to, like, say, return the position on the screen. You can only return one value from a method. So we're going to create a class called pointXY, and that will store the coordinate position, the XY position of a certain position on the screen. That way we can pass it in as one variable and we can return it as one variable. So let's do that now. And that should take care of our XY coordinate system. Now let's take a look at drawing an actual train car, creating the actual train car that we're going to have in our demo. All right, so let's create a class called train car. All right, we'll do the normal stuff. And we need a couple of variables. Now, some of the variables are going to be static. For example, the width of the car. We're not going to have to worry. We're not going to have different car widths. So let's create some static variables. And we also need the types of cars. And we'll just copy and paste this. Let's say we have 4 different types of cars. We'll have a caboose. We'll have a passenger car. We'll have the cargo car. And we'll have an engine. And these have to obviously all be different values. Okay, there we go. Now, what do we need besides the static variables inside this class? So, as I said earlier, we're going to have this goal trees object passed around everywhere, so every single object can access what's on that goal trees global class. For example, that goal trees class is going to have a reference to the display. We may need that because we may need to display something. So we're going to need a variable private goal trees. We're going to need one of these on every single object we create. All right, so here we have this global goal trees class object. Here's the name of the car. Here's the type of car, which will be one of these. And here's the position of the car. So let's create a constructor. And what are we going to pass into the constructor? Well, we'll probably pass in, well, we definitely need the global variable. We'll need the name. We'll need the type of car it is. And we'll need the position. And then we'll just need to set those variables now. Okay, perfect. So now what we're going to do is we're going to render our car. So we're going to need a method here called render. Obviously accepting a graphics object. And let's just, for example, do, oh, we have to import. Let's, for now, let's just draw a rectangle. So we'll basically just have different, I don't know, we can say like we have different colors. So all we're going to do is we're going to do g.fillRect. And what are we going to do? We're going to fill the rectangle with the, let's see, the position.getX, the position.getY, and then the width and the height are going to be the width and the height of our train car, which is going to be car width, car height. Okay. And what color are we going to do? Well, let's just set different colors for different cars. So let's just say, for example, if type is equal to caboose, then we'll do g.setColor. Well, let's actually create another line here for it. We'll do g.setColor, and we'll say it's going to be red. Okay, there we go. All right, so now let's check to see if we have a passenger car. Oh, I have to import the color. There we go. All right, so let's just copy and paste this code, and this will be an else if now. And we'll say if the type is a passenger car, then the color of the car is going to be blue. And let's copy and paste this code a couple more times. And we'll say if this is a cargo car, what color can the cargo car be? It'll be light gray. And if the car is an engine, whoops, engine, there we go. The color of the car would just be black. There we go. Okay, so that takes care of that. And then we're going to just draw a rectangle. That's pretty basic. All right, now we are going to need we're going to need a couple of methods here. So let's create some methods. Set position. We'll need, maybe we want to change the position of the car. And we're going to need some get methods. So let's create one for the name. All right, and that should do it for the train car for now. I mean, there's going to be more stuff obviously on here. Now let's go to our main class, goal trees, and let's add the car. So we'll first go into the initialize method, and over here, after we create the display, let's just create a temporary car. So we'll say, well, first we need a variable, obviously. So let's create a variable. We'll just call it TC for short, because this is just going to be test. We're not going to have this in here. You'll see later. But let's create TC is going to be equal to a new train car. And what did we say we needed to pass in? Well, when we create a new train car, we're going to need to pass in the goal trees object, the name, the type, and the position. So we'll pass in the goal trees object, which is this. The name of the car is going to be, let's just call it X1, or actually we'll call it P1 for passenger car. And then the type is going to be the passenger car. But if you remember, we created static variables for that. So we can just reference that. So we would say train car dot passenger. Now, what else do we need to pass in? Well, I think it's the position. We need to pass in the position of the car. So let's create a new point, XY, and let's just say it'll be at 200, 200. Perfect. Okay. So what else do we need to do as far as inside goal trees? Well, we don't need to do anything in tick yet because there's no variables to update. This is just test. But in render, when we say draw everything, again, this is just going to be test, but we do need to tell our train car to draw itself. So there we go. Okay, so now if we run our program, let's see what happens. And there's our car. That's our passenger car. Remember, it's blue. We can change the test car from passenger to say cargo. And let's see, that should be, I believe, gray. Yep, that's gray. We can do caboose and so on. And that should be red. And there we go. We have our passenger cars display. We have our cars displayed. Perfect. Okay, so now what I've done is I've taken the liberty of creating a little bit nicer graphics. So as you can see, I now have 4 test cars that are going to display. I have created all 4 of them, one of each type. And now in the render, I've rendered each of them. But in the train car, what I've done is I've actually changed, as you can see here, my render method. I'm drawing the base of the car. I'm drawing the wheels of the car. I'm drawing, if it's a caboose, I'm drawing a different design than if it's a passenger car, than if it's a cargo car, than if it's an engine. And again, these are unnecessary. It's just a way to make it look a little nicer. So if I run this, as you can see, now I have these 4 different kinds of cars. And all I'm really doing is just drawing a bunch of rectangles in different places. You could use images, whatever you like. Obviously, I'm not drawing a rectangle for the wheels. Those are ovals. Okay, the last thing is we want to display the name of the car somewhere on the car. Now, if you remember, we created this object, this class text, which we're now going to use. So let's go into the train car. We'll go at the bottom of the render method. And then over here, we'll display the name. So we'll call text.drawString. Remember, that's a static method. And what are we going to pass in? Well, the first thing we're going to pass in is the graphics object. Then we're going to pass in the string we want to display, which is the name of the car. Then we're going to pass in the X position and then the Y position. So that's the position of this car dot get X. And then we'll add half the car width. So we want to put it right in the center of the car. So car width divided by 2. And then the Y position will be position.getY. And we're going to go halfway for that as well. So we'll say car height divided by 2. All right, the next thing we want to do is pass in the true-false flag that determines whether or not we want to center the text at this position, and in this case we do. So we'll say true. And then we want to pass in the color. We'll use cyan. Okay, so that should take care of that. If we run now, as you can see, we have the name of the car written in the middle of each car, and that's exactly what we want. And we can use that to talk about which cars are going to move here, which cars are going to move there. Now, I'd just like to show you exactly how the train yard is going to work. Here we have a grid. Each grid position is going to be the dimensions of one train car. This will be, say, track 0. This will be track 1, track 2, and so on. In track 0, this is the position of the first car, or car 0. This is the position of the next car, and so on and so on. And there'll be a limited number of cars. And at the end of the train yard, we'll have this conveyor belt. So we're going to have this grid position, and that's how we're going to actually program this. So let's head back over to NetBeans, and what we're going to do is we're going to first open up goal trees, and we're going to remove all of this test code. So let's get rid of these. We don't need these anymore. We don't need these anymore. This was just for testing to make sure that the car is displayed properly, and we don't need this anymore. So the first thing we're going to do is we're going to create our track. Each track will have a whole bunch of train cars. So let's create a new class called track. And that's going to be one horizontal track that holds a number of train cars. As usual, we're passing in our global variable, which is going to hold everything in our simulation. We're going to need the name of the track. How many slots does this track have? In other words, how many cars can this track hold before it fills up? And the position, the coordinate where the track is going to be displayed. Okay, and now of course we need to declare our variable, so let's do that. And we're also going to need an array list of train cars. We don't know how many there are going to be, that's why we're going to use an array list. And then in our constructor, we need to initialize. Let's import this. All right, now, what are we going to need to do inside this track? What are some of the methods that we're going to need? Well, we're going to need the ability to add a train car to the track. So let's create one of those methods. And let's see, we're also going to have to tell this car the position where it's going to be. Remember, because a train car needs to know its position. So when we add a train car to this track, we need to let this train car know. Let's set its position, and let's create a new point. Now, where will this car go? Well, it's going to be the last position where there's a train car plus one position, right? Wherever the last car is on this track, we're going to move one to the right, and then we're going to tell that train car, this is where you're going to go. Okay, so there you go. We look for the last position. We multiply it by the car width. This is actually the first empty position, and then the Y position is the same as the track. All right. What else are we going to need? Well, we're probably going to need the first car on this track, right? Because when we're doing a whole bunch of processing, so we're going to need to know, like, hey, what's the first car on the track? So maybe we can move it. Maybe we can clear the front of it. You know, that's for later. So we're just kind of forward thinking here. So public train car, we'll call it get first car. And all we're going to do is we're going to return from the array list. Okay, so that'll give us the rightmost car on the track. What are we going to need also? Maybe we're going to need the first available position. What's the first open position on this track? Okay, so that'll give us the first open position, the rightmost open position on this track. What else are we going to need? We're going to probably need to know the number of train cars on this track. All right. What else are we going to need? We'll probably want a get method for the name of the track. Okay. So we're also going to need a render method. And what's going to happen here? So let's draw the track. So first we're going to draw, well, we have to import. Let's import. There we go. All right. So let's draw the horizontal tracks. All right. So G.setColor. We'll make them black. And we're going to just draw 2 lines. And we have to import for color. Just notice that. There we go. Okay. So draw a line. We're going to start at the X position of the track, which is the leftmost position. And where are we going to draw our horizontal line? Well, we want to draw the track not at the very bottom. Well, we want to draw a line at the very bottom of the track. So let's say this window here is one cell for a train car. The track is going to be down here, and it's going to be a little bit up. So the track is going to be way down at the bottom here. So let's draw a line starting on the left side, and for the Y position, we'll say it's the Y plus the train car height, which will give us the bottom of where the train car is going to sit. But then I think we want to subtract 10, whatever. We'll see how that looks. Okay, so we're going to move up a little bit. And then the line is going to draw from the left side all the way to the right side of the track, which is X plus the number of slots for this track, how many train cars are going to be held on this track, times the width of the train car. Right? So if the train car is 100 pixels wide and we can hold, let's say slots would be 10, we want to multiply 10 by the width of the car. That's how long we want this track to be. Okay, now the Y position is going to be the exact same thing. We're not going to go diagonal. So let's copy this. We'll put it here. And okay, there's our line. Now we want to draw another line exactly like this, just a little bit further down. So instead of subtracting 10, we'll just not subtract anything. So that's where the car is going to sit. Now, horizontal lines, that's not much of a track. We want vertical lines connecting the tracks. Let's do that. All right, so for this, we're going to need a loop. So we're going to loop from the left side of the track all the way to the right side of the track. And we'll space them out, like this, 20 pixels gap. All right, and this vertical line is going to go at the position I plus X, obviously. Vertically, it's going to go from the first track, which is the -10, to this one. It's going to go from this one to this one. Okay, so that takes care of the render method, except one thing. Remember, the track is going to be holding a bunch of train cars. So when we render this train track, we also have to tell it, hey, you got to render all the cars that are on yourself. So let's now render the train cars. Okay, wrong variable. T, there we go. Okay, it's it's bad when I misspell a single letter. Okay, so that should take care of the track. Now let's actually make a train yard. So we'll go to goal, we'll go here, we'll do Java class, we'll do a new class, we'll call it a train yard. All right, let's do the standard stuff. And what are the variables we're going to need? Well, we're going to definitely need this global goal trees. We're going to need, let's see, we're going to need a width, we're going to need a height, we're going to need the number of tracks that are on here. We're going to need the number of cars per track, right? How many does each track hold? And we'll need the, I guess, the number of train cars. Okay, the total number of train cars in this simulation. We're also going to need an array of tracks. So let's create that. All right, now let's create our constructor. Passing in our main variable here. So let's just set that. Okay, so now let's initialize some stuff. So number of tracks. I think when I did the demo earlier, I made it 16. I think that fit perfectly. The number of cars per track, I think we'll set at 8. The number of train cars. How many do we want in the simulation? Why don't we go with 15? Did I do something? Number of cars per track. There we go. Okay. All right, what's the width of our train yard? Well, the width is going to be the number of cars per track times, whoops, I need an equal sign here. It's the number of cars that we can hold per track times the width of a train car. Okay. The height of our train yard is going to be the number of tracks times the height of a train car. Okay. And we have to initialize our track array. Okay, there we go. And then not only do we have to initialize the array, but we have to create the tracks. So let's do that. The name of the track could just be track, followed by a space, followed by the number. That's fine. All right. Okay, and remember, I did it again. Remember that when we create a track, the things that we need to pass in after the name are how many slots, how many cars can we hold, and then the position of the track. So that's what we're doing here. We're passing in the number of slots, how many cars per track can we hold, and then the position of the track. The left side is always going to be 0. The x coordinate, I'm sorry, is always going to be 0. For the y coordinate, it's going to be the track number times the height of a car, right? If we're at track 0, we want the y position of the track to be 0. If we, I'm sorry, of the track. If we are at track number 1, which is actually the second track down, we want 1 times the car height. So we want to move down 1 car height. So that takes care of the constructor. Oh, and by the way, we also need to create the cars in the train yard. So let's call a method here, create cars, which obviously we have to write, and we're going to do that now. So let's create a private method. Okay, so there's our method, create cars. Now, how are we going to create cars? I kind of think that we should create random cars. So let's do that. We'll have a random track and a random car type for each car. And how many cars are we going to create? Well, we specified it here. We're going to create 15 cars. We made it a variable that way. If we want to create either more or less, we just have to change the variable. We don't have to go into here and look to see, well, do we need to change this? Do we need to change that? We just change it in one place. Okay, so let's create a loop. Oh, and when we create these cars, it's possible that even though we're randomizing the track, we could end up with a situation where we create too many cars for a track. So we're going to, if that's the case, we're going to need to pick a different track. So we're going to definitely need a variable called valid track, because we're going to need to keep track of whether the randomized track that we've selected for this new car is valid or not. And if it's not valid, we need to pick a new one. So first thing we're going to do is we're going to set valid track equal to false, and then we're going to pick a random track. Okay, we're not going to create random cars on all the tracks. We'll just pick tracks 0 through 5, which is really the first 6 tracks. Okay, so let's make sure that while we don't have a valid track yet, okay, so all we're doing here is we're just basically saying, okay, give us a random track, one of the first 6, right? And if it's not a valid track yet, which, I mean, they all start as invalid, right? So we're just going to do something. What are we going to do after we pick the random track? We're going to check to make sure that we haven't run out of room on that track. We're checking to see if that track has more than 4 cars on it. And if it does, we're going to add one to the track, and then we're going to loop back up here, and we're going to try again. See if that track has room, and so on and so on and so on until we find a valid track. And once we find a valid track, we change this to true, we break out of the loop, and then all right, so what are we doing here? Now, it's underlined in red. I'll explain that in a minute. So after we pick a random car type, once we find a valid track, we pick a random car type, which is basically an integer between 0 and 3, right? 0 is caboose and so on. And then we take the track that we've selected and we add the car to it. And how do we add the car to it? Well, we have to pass in a new train car. How do we create a new train car? Well, first we have to pass in the global variable. Then we're going to pass in the track that it's going to be on. That parentheses needs to go away. Then we're going to pass in the name of the car, which is basically just going to be the number I, right? Plus one, because we don't want to have car 0. We'd rather it be car 1, 2, 3, 4, 5, and so on. Then we pass in the type of the car and then the position. The position of the car we're just going to make null. Why null? Because when we add the car to the track is going to tell the train car which position it should belong in. So we shouldn't be doing that here. We're going to let the track handle it. Now notice this is still underlined in red. And the reason why it's underlined in red is because, well, a couple of reasons. First, we need to have a parentheses here. But then the second reason is because this train car, the constructor, is wrong, right? We added a parameter here that we really shouldn't have. Train car, where is it? Train car, the constructor takes in the global, the name, the type, and the position. We're passing in the global, the track, the name, the type, and the position. So we need to add the track to the train car here. Okay, so when we add this, what we're going to really do here is we're going to need a variable private. We're going to need to keep track of the track, no pun intended. There we go. Okay, that's the track that the car is on. And then we're going to need to set it here. And then we're probably going to need a get method for the track. So let's do that. All right, and that should take care of the changes to the train car. So let's make sure, yep, that goes away. All right, now what else do we need to do in the train yard? Well, we're going to need a tick method, okay? Remember, the tick method is the thing that updates all the variables, and that's going to be called 60 times a second. So let's create that method. And what are we going to do? We're just going to tick all the tracks, right? All the tracks are going to have to be updated. All the tracks are going to have to update its variables if necessary. We don't know what's going to happen there, but we know that the train yard contains tracks, and every time we're going 60 times per second, we're ticking the demo. Every time we tick the train yard, we have to tick all the tracks. So let's do that. Now, notice there's no method for tick on the track. Well, obviously, we haven't done that yet. So let's go to track and let's create a tick method right here. And for now, we're going to do nothing. Okay, we're not going to do anything. We'll put that in later because we don't have anything to do. We don't have any variables that we need to update. So now let's go back to our train yard and let's go to render. Okay. So now, what are we going to do when we render our train yard? Well, the first thing we're going to need to do, obviously, is import graphics. Okay, so what are we going to do when we render the train yard? Well, we're first going to create a border around the entire train yard. So let's just write border, and we'll do g.setColor. We'll make it black, and then we'll do a rectangle. Okay, so draw a rectangle. We'll just start at 0, 0, and we'll just go width and height. Okay, so whatever the width and the height are of the train yard, that's what we're going to draw. So now let's draw the conveyor belt, which is all the way at the right side. So let's do g.setColor, and we'll make it gray. Let's see, we'll do. All right, so first we're going to fill it in with a grayish color. It's going to start at the width of the train yard because, right, this is going to be to the right of the train yard. So whatever the width of the train yard is, that's where the conveyor will start. It's going to move horizontally one car width, so it'll be exactly one car width wide. And then for the Y position, we'll start at 0, which is all the way at the top of the train yard, and go all the way to the bottom of the train yard. Okay, but we want to have like little horizontal stripes to make it look more textured. So let's create a loop and let's do those. So g.setColor, we'll do dark gray, and we'll have our loop to create these stripes. Okay, there we go. Now, the train yard is going to contain a bunch of tracks, so that now after we've drawn the train yard, the border, and the conveyor, we need to tell all the tracks to render themselves. Okay, that should take care of the train yard. Last thing we need to do is we need to go back to goal trees, And in place of all that test code that we took out, we have to just create the train yard. So let's go here. We'll create a train yard. Okay, and now in the constructor, we need to actually create the train yard. Okay, in the tick method, we need to tick the train yard. We're probably going to need a get method to get the train yard. So let's make one. And oh, I forgot. I completely passed over it. We have to draw the train yard, right? When we're drawing everything, we're just going to tell the train yard to draw itself. Now let's run and see how it looks. And there's our train yard. Okay, we have all these tracks. Perfect, right? Now, here's the conveyor, and this will be the area where we have our text display and our buttons. Now, we like to keep these videos within a certain range in length, so we're going to put a cut in the video now, and we're going to pick the rest of this up in part 2 of Goal Trees. Well, I hope you enjoyed this video. If you did, be sure to smush that like button and subscribe to the channel. We've got some really cool stuff coming up. Bye.